Welcome to week 2 of Level C Math in spring 2021. We just talked a little bit about the achievement page and how the syllabus now has a week 2 foldout. We also think that Wednesdays 1 to 2 p.m. might be a good time for another study session. So that will all show up in the after class email. But what we're doing now is keeping going in math. So last week we talked about rounding and decimal accuracy and estimating. There were 10 exercises that went with those topics. Does anyone have questions as we start class about the 10 exercises for rounding or anything else with rounding?
No.
So since no one does, it seems, then rounding now has a due date. Rounding is due next class, because apparently you're all good at rounding. You don't have questions anymore. So if you've done it already, great, you're ahead of the game. And if you haven't done the rounding 10 exercises, then you have a couple. Then we got almost through fraction format of stuff with one number. We thought about division, we talked about divisibility rules, we talked about factors, how to change a denominator to something bigger that you want, or how to reduce a fraction to something smaller with the denominator you want. We talked about going back and forth between fractions and decimals by either saying its formal name and reducing, or by dividing. And then we were done. We ran out of time. We haven't gotten to ratios and rates yet. So I don't want to ask for questions about the 10 exercises for fraction format yet. We'll get to them soon enough. It makes more sense to talk about ratios and rates first, so we actually have everything. But if you had questions on these earlier topics, then we should probably answer your questions now before we dive into ratios and rates. Any questions about the topics we did last week there?
I'm good.
No here.
Okay, there'll be some review as we go, so it's not like you're never going to see this again in class. Okay, well, let's start with ratios and rates. And this is just how things are, right? The math doesn't care if this is math level C or math 20 or whatever we call it. There's sort of a right order to do things in. And we start at the top and go down. And it is better for you to have lots of questions. If you don't, then we just wind up having more review days at the end of the term as we're panicking about the final. You will ask your questions at the end if you don't now, but it just feels better to go at the right pace. Whoops, wrong click. Okay, ratios and rates. The brown numbers again are where they are in the free textbook. And I do have some news about that. The grant money did arrive. So it'll take a few days for the purchase to actually happen. But maybe as soon as Thursday, I will have some codes for you to be able to look at the free textbook at the top of all of these pages and get all those nice extra videos and things like that. And I'm not sure how ABSE handles the physical book. If you have to stop by LCC and they like walk out to your car and hand it to you and here is your loaner textbook, or what will happen in this crazy remote term. But feel free to make a fuss. If you prefer having a physical book to work at, many people do, then that can probably happen. But it might not happen unless people make a fuss. Okay, anyway, that's these little hiding numbers up there. So far, all of our fractions were proper fractions. They were like cake slice numbers. The denominator, the bottom number, counted the number of pieces. We have fourths. And then the numerator, the top number, counted how many were shaded. I'm eating 3 of the 4 pieces of cake tonight. So if you're a cook or a carpenter, then those are important fractions you'll deal with all the time. But for many people, their real life fractions aren't like that. There are fractions that exist without any sense of total pieces or shaded pieces. So we'll get to that in a moment. So when is a fraction not a fraction? First, we should notice something interesting about fractions and division. We know that we can change fractions to decimals by doing division. That's how we ended last night. And I'm again going to check as we're looking at formulas. Is the font big enough? Do you want it bigger by 1 step?
I think it's good.
that too big? Is that better?
Yeah.
So we can take a fraction like 1/5 and say it's 1 divided by 5. Either do that long division, do that on the calculator, and there we go, it's 0.2. I can even get out the Desmos calculator and say 1 divided by 5, and it's 0.2. We often reduce fractions. And in that sense, fractions are not like division, because if I did 10 divided by 5, I would never change that into 2 divided by 1. That would look very weird. Right? People don't do that. We just do 10 divided by 5. So we talk about equivalent fractions, but we never talk about equivalent division problems. Hello, by the way, if you haven't yet, say something, even just the word here in chat, so that when I take attendance, I will know you are here. And then if you stick around for the study group afterwards, I'll have you say here again, so that we can get you checked off for that achievement. Okay, so the first clue is that fraction format is a good way to patiently wait like a vulture for spying on the situation that might involve division soon. And this happens all the time when we compare numbers. A package of 24 energy drinks costs $35.99. Does anyone care how much one drink costs? Maybe we need to do $35.99 divided by 24. So we will kind of lurk and wait. Do we need that to happen? Or a contractor submits a bid. It costs $2,800 for a 120-foot long fence. Does anyone care what this costs per foot? Maybe if we're comparing this contractor's bid with another, we want the per foot price. So we can just kind of wait. Do we need to do 2,800 divided by 120 or not? We'll see if the division will happen. So that's the job for a ratio. A ratio is a comparison of two numbers, usually written as a, and since we have a good definition, I am going to put it on the Jamboard because that's the kind of thing we should do. So in our previous examples, we could take the energy. And rate them like a fraction. So this is going to be $35.99 over 24. And this isn't really a fraction. It's not like the bottom has how many parts there are total, and the top is how many parts we care about. And philosophically, it's very different than 3 out of 4 pieces of cake. But we can still do all the nice tools we have with fractions with this ratio. The other one we had was the contractor. So we could write 2,800 divided by 120 feet. And I should actually be good and put a label here too. We'll see later that we like labeling our ratios. So once again, it's not like this is how many feet we care about and that's how many feet there are total. It's not a normal kind of fraction. We're just using the fraction format to compare two numbers. Now, just because we're doing this doesn't mean we can't have a sense of total pieces and shaded pieces. There used to be commercials all the time about breath mints. We interviewed dentists and 8 out of 10 dentists approved of our breath mint. So how would we rate that or write that as a ratio? Don't think too hard. We're just writing one number on top of another.
10/8.
We could do 10/8. We could also do 8 out of 10. Notice that since we're just comparing things, it doesn't really matter which one we write on top, which is another way it's different than normal fractions, right? If I had 3/4 a piece of cake, I can't just decide, let's write it upside down as 4/3, right? So one of the reasons that we like labeling things is that it helps us know what's happening when we flip it. This was 10 total and 8 approved. Or we have our 8 approved on top and 10 total. Right? So both of these are good ways to do it. Whereas this is just kind of can't flip. There's more than just a comparison happening here. Other ratios don't have a sense of total pieces and shaded pieces. So the Red Baron can fly 38 miles in 40 minutes. How would I write that one? Again, don't think too hard. Just tell me one to write on top of the other.
38/40.
38/40, good enough. If you wanted, you could label it miles and minutes. If you wanted to flip things upside down, you could. We have a lot of flexibility here. There are even ratios with a hidden sense of total pieces and shaded pieces. So if I look at this one, the classroom has 4 left-handed people and 16 right-handed people. I could write 4 to 16. How many total students are in the classroom?
20.
20. I'd have to do a little bit of arithmetic in my head to get that. So they're not hard to do, just writing one number on the other, but it's a little bit different than the traditional kind of fractions made out of cake pieces that have a part over a whole. And as I mentioned already, we can turn things upside down. That's okay. It often does not make sense to reduce a ratio. If I have 4 left-handed people and 16 right-handed people, and I reduce it, I mean, I could, right? Divided top and bottom by 4. The math is nice. There's nothing wrong with my math reducing it. But nothing in real life that I'm looking at has a 1 compared to a 4. This is some fictitious, smaller classroom with only 5 students in it. Or similarly, if I took the breath mints and I took my 8 out of 10 that liked it, and I multiplied it by 10, top and bottom, I could get 80 out of 100. That's an equivalent fraction. Nothing wrong with that as far as the math. But now I'm kind of bragging. This looks like I interviewed 100 dentists, and I didn't. I was more lazy. I only talked to 10 of them. So again, we can reduce and unreduce, but it doesn't really match what's happening in real life anymore when we do. So often we don't. Okay, Some ratios include words. We've talked about labeling that. And so a rate is when we take our ratio and the numbers have labels and they're different labels. So I'll just stick that there. Total and approved, that's different enough. This is a rate, 8 out of 10. When we have rates, we often use words like 8 out of 10 or 38 miles per 40 minutes. So out of and per and things like that kind of are the words for the fraction bar. If we divide, we get a different rate whose second value is 1. And we call that a unit rate. It happens so often, there's a name for it. So let's make unit rates out of our example rates so far. If we had eight out of 10 for the dentists, then if we divided the top and bottom by the denominator, then we get 0.8 over 1. That's our unit rate. So we could say 0.8 of all the dentists approved of the breath mint. Or if we had 38 miles and 40 minutes, I could again divide top and bottom by the denominator.
You wrote 30.
Yep, I'm dividing by the denominator for both. Oh, is it 30? Oh, 38. I see what you said. Thank you. Thank you for correcting me. Now I actually have to get out my calculator. What is 38 divided by 40? So 0.95. This one I might write as 0.95 miles per minute. Or 0.95, I could use the word per. So this is something we do all the time at the grocery store. What's the price per ounce or price per pound or price per gallon of something? We take the top number and the bottom number, we divide them both by the bottom number, and we figure this out. Okay, do I give you a example? Let's just do this one. So Kim solved a 300-piece jigsaw puzzle in 90 minutes. So I'll take my 300 pieces, divide it by the 90. 300 divided by 90, and we get 3.3 repeating. Does everyone know the bar over the top to mean repeating? I should make it look like a flat bar. So there we go. All it is division, just a specific context of we're wanting a per, we're wanting an out of. So we are comparing two numbers and doing top divided by bottom. I mentioned the per here in the notes. So the only tricky part is that for our ratios and rates, it doesn't matter if we flip them. And some people will do this one way and some will do this the other. So I'm going to put this small on the Jamboard just so you know what we're talking about. But then I'm going to write these bigger and slower so they make more sense. Okay, I'm shopping for a fancy hand lotion. What's a better deal? 10 ounces, OZ is the ounces abbreviation, for $5, or 24 ounces for $8. So this one becomes 10 divided by 5. So we have 2 ounces per dollar. Remember that we are going down, treating the fraction bar as the word per. So we have to say ounces per dollar, the way we have written it this time. Similarly, this one, 24 divided by 8, is going to give us 3 ounces per dollar. 24 divided by 8 is 3. Which one is the better deal, assuming we don't care how much we buy?
The first one?
10 ounces for 5.
For the first one, if we spend $1, we only get 2 ounces.
Oh, the second one.
Second one. So we want the bigger, more stuff per dollar. And for some of you, that will make a lot of sense. And for others, that will seem odd. Because a bunch of people think the other direction. Let's flip the fraction. We'll start with $5 compared to 10 ounces. Or $8 compared to 24 ounces. So this one is going to be 5 divided by 10. Again, we go down the fraction with our division. So now we have dollars per ounce. And we probably wouldn't in real life write it that way. We would make it look like this, right? 50 cents per ounce. This one, we have our 8 divided by 24. So then we'd get 0.33. It keeps going, but who cares? And again, instead of dollars per ounce, I'm probably going to write it that way just because that's how English works. And it's still true that this is the better buy. But now we're picking the smaller. We want less
Oh.
money per ounce. And again, everyone that didn't like this slide, now they're happy with this. And some people think this looks funny and they were happy the first time. The first way of thinking is sort of like imagining I want to make a fancy cake for somebody. And I'm sorry, this one is thinking I need to fill up my car at the gas station. I'm going to top it off. I go to the gas pump. I say, I am putting in $1. Give me as many gallons of gas as I'll get for my $1. Because for some reason, I only have $1 in my wallet. I want the bigger number because I'm dividing and the money is at the bottom. Other people will say, I want to make a fancy cake for someone. I never have coconut shavings at home. I need some pieces of coconut shavings. I'm never going to use them again that I know of. I just want to go to the bulk aisle of the grocery store and get a few ounces of coconut shavings. I want to pay as little as possible for this fixed amount of coconut shavings that I'm trying to buy. So I want the smaller dollar amount because how much I'm buying is fixed. So they are both good ways to think about things, but for almost everyone, one of them feels very natural and the other feels like we're doing it wrong. So you don't have to do both, but just realize that there are both, because if you're sitting down with a study session, the person you're working with might have the other kind of brain and they will try and do it this way. And don't yell at them. They are doing it an okay way. They're just doing it the other way. And pay attention to if you want the bigger or the smaller answer. So that's what all of this was about, slow and careful. And that's all there is. for ratios and rates. So again, at the end of a subtopic, we get lots of videos. This is one that many students have gotten that achievement, picking a new video. So we have a whole bunch of them. We still have the YouTube problems where you can click to get the video, or click here to get all the steps, or just see the answer based on how much help you need. If you have that textbook code, again, hopefully soon, and you want to do a normal amount of homework before you jump into the 10 exercises, make sure that you're not confused about things before you turn something in. Then these are kind of the efficient number of problems. Maybe you need less, maybe you need more, depending on how good you are at this already. And once again, if you are in the textbook, no, I have to go up here. If you're in the textbook, then the place to check your work at the end, for some reason, it's not progress check. That's what it sounds like, but it's in supplements and then selective answers. And the answers to the odd number problems then pop up right there. Okay, goodbye book, back to here. So your flow of things should be that you review what we did, because it makes sense now when you're all relaxed, but when it's your turn, it will be like, it left my brain, where did it go? Right? That happens to everyone. And so do a few homework problems and say, yes, I got this, now I understand. And then you go to these 10 exercises. When you're done with them, click on the form, and it's the same things, but with the multiple choice. You'll pick a few bubbles, and at the bottom, make a code, highlight the code, and copy and paste it and send it to me, and I tell you how you do. And if you didn't hear this spiel earlier, the reason we do it this way is so you get personal feedback very quick all the time. Usually within a few hours, I'll write back to you, sometimes quicker. If you have had a math class where you turn in the homework and the instructor puts red all over your paper and you don't look at it, you just stuff it in your backpack and forget about it forever, then that doesn't help anyone. So making sure that you keep trying till you get 8 out of 10 right, and I can keep grading it because the code makes it quick and efficient for me. And then lots of attempts if needed. You know by the end that you've mastered this stuff. And there we go. Okay. So I guess the next question then is, these 10 questions. I don't want to do all of them now because we're just finally getting to where we can really assign this homework. You could have done the first 7 at the end of Thursday's class last week. So some of you have started that. And a couple of students even just did all 10 and got 8 out of 10 and were happy. But you really weren't expected to start this until now. But I will do a similar problem. If you're curious about any of these, I will put it on the Jamboard, change some numbers, and do the other version of it. Anyone want me to do more of these?
I think I could work with it.
Are there people that missed the lecture last time about divisibility rules? For almost everything we do, the danger is you're going to make the problem harder than it is. So I'm especially worried with these that people will try and do long division or waste a lot of time, and that's not what I'm asking. No, okay, well, next time you can ask them too. So again, your flow was review the notes, maybe look at some videos, try a few problems to check if you're doing them, do some of the homework in the book, then turn this in. And if that's not enough practice, then that's what these random exercises are for. Because there are some students that complain and they say, I need more homework, or at the end of the term, I need different homework to make sure I haven't forgotten this before the final. So these problems with letters will change every time you load the page and the answer key is there. These are also the ones that will someday be on the final. Okay, we did the interlude of If I'm in the Right Math class already last time. Are we really ready to move on to percent format? I don't want anyone to feel rushed. We have time.
I'm ready.
I'm ready.
Okay, again, here's our textbook section. Now we're doing everything with just one number at a time with percents. So as we transition from fraction format to percent format, we can't do that quite yet. We have to review when we multiply by powers of 10. So let's look at that. Okay, if you remember the trick, then call out what these are. If not, feel free to cheat with a calculator. It says you're allowed to. It's not cheating now.
It's just moving the decimal point over one, isn't it? For 10.
For A, it's, whoops, one, I have to write the numbers correctly. 1, 2, 3, 4.56. There
And
was
then 2 places for 100.
one scoot. Oh, okay, Joel says 2 places there,
And 3 for 1,000.
3 for 1,000. And I could write a 0.0, but that would be kind of funny and also kind of bragging about accuracy that I don't have. So the decimal scoots to the right. And what most students like is the same number of zeros is how many scoots. So 10 has 1 0, so it's 1 scoot. 100 has 2 zeros, so it's 2 scoots. 1,000 has 3 zeros, so it's 3 scoots. Okay, division. I'm guessing you know this because you did the other one. So
You move it back one, the
instead
first
of
one.
going to the right, now we're going to the left.
For 100 and 3 for 1,000.
Yeah, 2 for 100, 1, 2, 3 for 1,000. So same thing, the number of zeros is how many scoops. Does it make sense that when I multiply things by big numbers, my answer gets bigger?
Yes.
Yeah, if I have 123, whatever, grains of salt in my pocket, and I have 10 times that happens, then I have 1,000 grains of salt, right? Does it make sense that when we divide by big numbers, things get smaller?
Yes.
Yeah, if I have 123 things and I share them with my 10 friends, then we each get about 12 of them. Okay, now What about decimals? If you haven't memorized this one, just grab a calculator, use your smartphone. You can discover the answer.
It scoots back.
It does. So this one becomes the 12.3456.
0.6.
What happens with times 0.01?
Huh?
It moves back.
Keeps moving back.
It moves back now twice. And with 0.001,
It moves thrice.
twice, yes.
But why? Didn't we just do that for the,
Let's compare. Here we were multiplying by big things. This doesn't really look like money because we have 3 decimal places, but I have about 123 bucks. Somebody pays me that every day for 10 days, I have 1,000 bucks. So when I multiply by a big number, I get copies of my money. I get more money. When I want to translate this one, then I might write 1, 2, 3.456 times 0.1. What does times turn into when we turn equations into normal sentences? We have words like is and of and per. Which one was times? We can look at this one. Do we say I have 10 per 123 bucks, or do I have 10 of 123 bucks? Per is actually the division one. So times is of. I have 10 copies of 123 bucks. I have 1,000 bucks. So here, if this is of, and 0.1 is 1/10, then I have 1/10 of this. It's getting smaller. So if I multiply by a tiny thing, something less than 1, it makes me smaller. It's like I'm dividing. I took my paycheck, I had to share it among the 10 people I lived with. I only got 12 bucks for spending money myself. Like I took my cake, this giant brownie, I cut it into 123 pieces. I got 1/10 of the pieces, I only got 12 of them, something like that. So because these are fractions, they're decimals, they're things less than 1. They're tenths, hundredths, thousandths. They're tiny little things. So if that's all you get out of it, it gets smaller.
That makes more sense.
oh,
Okay, and then lastly, again, if no one has taught you this, it's not your fault. Take out your calculator, you can figure it out yourself. What's the pattern for divided by the itty bitties? I'm going to start writing them down here.
It starts going forward one and then twice.
So division makes it backwards. Dividing, I'm sorry, not division makes it backwards. The tiny things, the decimals make it backwards. They made it shrink when you multiplied, and they make it get bigger when you divide. And we'll talk about why in a moment. Okay, again, you could put a 0.0 at the end if you wanted to, but so division means per, just like we did with the fractions, just like we did with the ratios and rates earlier. 10 ounces per $5 is 2 ounces per dollar, or $5 over 10 ounces. We could write that going down with per as $5 per 10 ounces, or 50 cents per 1 ounce. And so division is about per. I'm saying that whatever I get, what's something that you get 123 alpha for every 10th of something else. It feels like when I'm driving on a road trip, for every 10th of a mile, my kid asks, are we there yet? 123 times. So if I actually went a whole mile, it would be 1,000 times my kid asks, are we there yet? Because every 10th gives me 100 of them. My kid actually doesn't interrupt that often, but there we go, right? So if you are per a tiny thing, then by the time you look at, per your whole amount, because divided by 1 doesn't change anything, then you get more of it. If you had some amazing job and you got paid $123 every 1/10 of an hour, then when you worked a whole hour, you'd get $1,234. Okay, so how do you remember that? Then how many scoots? It's the same pattern if you write that optional 0 before the decimal point. 1 0 means 1 scoot, 2 zeros means 2 scoots, 3 zeros means 3 scoots. If you don't, then it's not that the math is wrong. It is still true that I can write 0.1 as 0.1. That's just the more casual name as opposed to the I'm dictating in a math class name. But if you leave out the optional 0, then you don't get the nice pattern that the number of zeros is the number of scoots. And the same thing happens when we were dividing by itty bitty numbers. If you put that initial 0 in, the optional 1 in the ones place, then the pattern fits and you don't have to memorize anything else. Okay, should we do some more for practice?
I like that.
Oh, okay. Let's just do a few. And I don't think I necessarily want the first few though. Let's do these. And for the division ones, let's do goes. Okay. Okay, call them out if you see the answers. I will first check. Did we write our optional initial zeros before the decimals? Yes. So it's always true that the number of zeros will be the number of scoots. Your only job is it left or is it right? For
The
this
first go right.
first go right. We're multiplying by something big. We have lots more copies of it. So yes, that's going to be a big thing. 3, 1, 4, 6, 7. And we even need to put this extra 0 here because we scooted past the number. Does that ring a bell with everyone? You've seen that before?
Mhm.
If you haven't, holler and I can explain why with more detail. Okay, 1, 0, 1 scoot. Are we going left or right when we multiply by a tiny thing?
Left.
Left. Okay, 2 zeros, 2 scoots. Are we going left or right when we divide by a tiny thing?
Right.
Okay, how about the next one?
You going right 3 times?
Yeah, right 3 times. You got it. And lastly, divided by 100.
And moves it to the right twice.
Almost. It's not right twice. If I have to share my 59 bucks with 100 people, I'm not going to have much
Left.
left twice. I'm just going to have about 59 cents. So if you need more practice, all the answers are here. Once you learn it, it's like riding a bike. You'll never have to spend time on it again. Okay, you have a video. You have a few homework problems. Onward. So 4 replacements for the percent symbol. This is one of the most important things we do all term. But first, we're going to talk about rating scales. Our society is used to having numerical rating scales to rate how nice things are. So let's do this. Actually, I want this on the other. Oh, okay. So what do we think? How do we rate jogging? No right answer. I just want to write some numbers down. On a scale of 1 to 5, how much do we like jogging?
2.
2. Okay. How about banana flavored runts? That's a candy that everyone tends to love or hate in my experience.
4.
4. Elevator music?
Get down.
3, I heard.
Get down. Get down.
Okay. How about if we change it to a scale of 1 to 10? How much do we like jogging?
2.
They'll say 2.
You've gone up before.
4.
4. Someone says 4. How about on a scale of 1
to make her. You're an asshole, Copper. You're not good for training. You're in trouble.
and mute Tiffany for a moment because she's having dog issues. Okay, elevator music, scale of 1 to 100. What should I write here?
1.
1. Really don't like it. Okay, so we're used to this kind of thing, right? So in English, the popularity of product reviews on Auto Club travel guides means a star, we assume, is 1 to 5. Amazon too these days. So if I go to a hotel, fancy vacation, and say it's a 5-star hotel, Ruthie isn't going to go, poor David, 5 out of 100. Why did he stay at such a dumpy hotel? Right? She knows a 5-star hotel means good. There's no nice name in English for the scale of 1 to 10. The scale of 1 to 100 used to be called per cent, meaning per 100, because the word cent means 100, just like 100 cents in a dollar. But over time, the 2 words per cent got squished together, and now we just have percent. Right? So we're going to talk about this. Percent means out of 100. And so whenever we see a percent symbol, we can replace it with other things that also mean out of 100. So if I had 47%, I could say, well, out of 100 is just divided by 100. So I can take that 47% and peel off that percent symbol and replace it with divided by 100, because they mean the same thing. As we just saw, divided by 100 is also 2 decimal point scoots. So I could peel off the percent symbol and replace it by 47 with 2 decimal point scoots. I could also take the 47% and replace it with 47 over 100, because that's another way in math to mean out of 100. And lastly, I could take my 47% and rewrite that as 7 times 1 over 100, because that's yet another way to, that doesn't help, write out of 100 in math. So I have 4 different things. I can write it as divided by 100, 2 decimal scoots, over 100, or times 1 over 100. So what we will do next is look at different things we do with percent and see which of these 4 is the easiest thing in that situation. Sometimes it will be one of these, sometimes it will be a different one of these. But we want to be lazy and do whichever one gives us the answer quickest. Sound good?
Yep.
I can't see that last one you did.
You can't see that. Let me make the screen taller for a moment. If your screen bottom is covered by your Zoom control bar, you can also just drag that to the top of the screen.
Not muted. I'm not muted. Thank you.
Okay, everyone got this in your notes?
Okay.
I'll flip back to it, but for a lot of people, it's easier to have this in front of you while we do the next little bit of stuff. Okay, one moment. Okay. I'm shrinking it to the right size. So that's our 47 I just did. There we go. We could also talk about out of 100 with this kind of picture. So if I want to do first 47%, how many of my boxes, oh, one moment, let me back up. I'm going to want to paste it differently. I'm going to want 3 of those, won't I? So that I will put here. And then I will put 3 times.
Laptop, come. There's some something.
Okay, now I'm ready. So 47%. How many boxes will I shade on my 100 grid? 47. So 10, 20, 30, 40. There we go, right? Please, again, forgive my unexpert artwork. That's not why I'm here. Okay, what about 4.7%?
Five.
I shade almost 5. I would shade 4. And then I would go like most of the next box, but not all of it, right? See if I can make that look like 7/10. Again, artwork is not my good point. Okay. And 0.47%. What would 0.5 of a box be? Half. This is a little less than half of a box. So it's okay if my percents have decimals in them. That just means I'm not shading a whole box. I can also have percents that are bigger than 100. If I have 200%, that means something has doubled. My rent has doubled, my income has doubled, something like that. So it's okay if percents are bigger than 100 or less than 1. It just means I might need more than one of something if it's bigger than 100, or I'm shading in parts of boxes if they have decimals. Some people use circles. Okay, so there we go. We've talked about percents a little bit. Now let's put it all together. I'm not asking if you have questions, because if you do, we will talk about them right now. We had those 4 ways to create out of 100. If we want to do percent to decimal, which of those 4 ways is easiest? I now have 47.1%, and I want to get rid of that percent sign and replace it with something else. Which of those 4 things is easiest?
It'd be division.
No, I'm lazy. I don't want to do division if I don't have to.
42 times 1/100.
No, I'm even lazier. I certainly don't want to get in the world of fractions. What's the lazy option here with a decimal?
Oh, right, you move it.
The scoots. Yeah, that's why we did scoots a moment ago. So I'm going to scoot my decimal point. And get my answer. So percent to decimal is really easy. You just scoot twice to the left. So let's do more of them. Oops. Just because I say it's easy doesn't mean we don't get to practice. Because practicing easy things also helps. But writing that tiny is not gonna work. Okay. So if I have 3%, does it help if I color my percent symbol in a different color as I do these?
Yeah.
So I want to keep that 3, but replace the percent symbol. What do I replace it with?
Decimal.
The 2 scoots. This one I need to write in a 0, right? So I'm going to get 0.03.
So it's always 2 scoops?
Always 2 scoots because percent always means out of 100.
Oh, right.
So 30%, I'm going to keep my 30. I'm going to get rid of the percent symbol
2 scoots back.
So my 2 scoots left. And I get 0.3. This one I probably would just write as 0.3 and not as 0.30, but 0.30 is also the same number. It's fine. Okay, how about 103%? I said a moment ago that you can have percents bigger than 100. I'm going to keep my 103. I'm going to replace the percent symbol. So I get 1.03. Notice that the 1 means the whole thing, and the 0.03 meant the 3% more than it. So 103% is the 100%, the whole thing, and the 3% more. We can see that in the percent symbol format, and we can see it in the decimal format. Okay, last one, 10.3 with the percent symbol. It's still 10.3, but I'm going to replace the percent symbol. Scoot, scoot.
0.103.
I like writing the 0 in front just because I'm lecturing, but you don't have to. Okay, you got this. So the next thing is, of course, the other direction. So now I want to take, what's my example, 0.75. It's a decimal. And what I want to do is put a percent sign on it that wasn't there before. But that changes the number, right? That's like divided by 100. I can't just divide things by 100 because I want to. That changes them. So if I put a percent sign there, I also have to put the opposite of a percent sign on. So they undo each other. I want to take a few steps forward and a few steps back and get back to where I started. So what's the easiest of these to do the opposite of?
Move your decimal the other way.
Decimal, the second one again, right? So instead of 2 scoots to the left, I am undoing with 2 scoots to the right. And I'm getting 75%. Does that make sense? I'll repeat what I'm doing. So I have something that has no percent at all. I want to just slam a percent sign on it. But if I do, I have to also undo that to get back to where we started. And the way to undo a percent sign is 2 scoots to the right. So 0.75 is 75%. Okay, again, let's do more of these. So I have 0.04, 4 hundredths, a tiny amount. How much is that as a percent?
%.
Percent. I'll do my 2 decimal point scoots, and that allows me to put a percent sign at the end. Or I have 2.3. I have 2 copies of something and almost a third more. If I want that as a percent, oh, what happens when I go past the edge of my number?
0.
0. So 2 of something is unsurprisingly 200%. But this is more than 200%. It's 230 because I had more than 2 of the thing. 0.375. Don't be confused by how many decimal place values you have. You are always scooting twice because percent is always out of 100, which was 2 decimal point scoots. What happens if we have a repeating decimal, 0.666666 forever? I will do my scoots. Does the decimal stop repeating? No. So it is now 66.66666 repeating. So that's not bad. I'm just scooting my decimal, depending on if I'm going from percent into decimal or decimal into percent. One way I scoot left, one way I scoot right. Decimal scoots are easy. We need a shortcut or a memory device. So here we go. The acronym RIPLOP reminds us what we just did. It stands for right into percent, left out of percent. When I went out of percent to decimal, I scooted left. When I went into percent, from decimal into percent, I scooted right. So right into percent, left out of percent. So when you hear me say RIPLOP, or I will write RIPLOP, then this is what I'm doing. I'm changing a number from either percent to decimal or decimal to percent. So far, so good?
Yep.
You will see this all the time. So normally I would stop now and say, do we need more examples? But we will see so many of them. Okay, now we get a little harder. Fractions are always trickier than decimals. So I have 42%, and I want to make that a fraction. And it's no longer true that my decimal point scoots the easiest thing to do, because I don't want to scoot my decimal point. I want a fraction. So what's the easiest way to make a fraction?
You put it over 100?
Put it over 100. Yeah, I just write over 100. That's not hard. Ta-da! Now I want to say, ta-da, I'm done, but I'm not. Why am I not done? I got rid of the percent sign.
You have to divide it by 100.
No, that's going to make a decimal out of it.
Simplify.
Simplify, yeah. So the annoying guy whose name got lost to history, who made the rule that we all have to now follow. Whoops, not 21 divided by 2. Fraction answers aren't done unless we have simplified everything. Okay, now I'm done. So it starts out really easy because percent just means out of 100, I write over 100, but then I have to check. Do I actually simplify it or was I done? Okay, how about 80%? Try it yourself. And when you're done, tell me what to do.
(80/100).
Yeah, so I'll take my 80. That's a percent. I want to get rid of the percent.
80/100.
I'll write the 80 over 100. Am I done?
Nope.
No.
I'm pretty sure you can divide it by 4, can't you?
4 works. But just because of space on the screen, I'm actually going to divide it by 20.
Yeah.
So if you did 4, you just have to keep going a few
Yeah.
more steps. Nothing wrong
Yeah.
with it at all.
It'd be 4/5.
4/5. So if you didn't do 20, then just keep going until you get to 4/5. You'll get the same answer. But I'm going to run out of space if I try that.
Are you sure you don't want to do it with a 4?
I can write it as the 4. I'm just going to
I
write.
know.
I'll write it down here with the 4, and then you can't see the bottom of the screen. I'll have to fudge it and move the screen around. So this becomes 20 out of 25. And then I'm
Yeah.
going to divide top and bottom by 5. And then I get my 4/5. So it just takes another step. I just didn't want to try and squeeze that in right here. 'Cause- Okay, all good?
Yes.
So that's percent to fraction. So simple process, write it over 100 and see if you need to simplify. Now, this one, I'm going to not talk about right now. It will disrupt the flow too much. This is for next time. So if you want to be a superstar on Thursday, look at this one between now and Thursday, and you can be the one that teaches us what to do. Remember, you can actually peek at the answer, but this is complicated enough that you can show off. The rest of us are just going to move on to fraction to percent. So if I want to write 7/8 as a percent, I'm going to take that 7/8 and I want to put a percent symbol on and do the opposite. And none of these opposites work well. Like, what would the opposite of this be? I have to make it a fraction with 100 on the bottom and then take off the 100 or something like that. Not all fractions turn into 100, right? I can't unreduce 8 and make 100 out of it. So yeah, I'm actually, on this case, for fraction to percent, going to say, you know, we already know how to do decimals to percent. And we already know how to do fractions to decimals. And the easiest thing is just going to do both of those. I will first say this is 7 divided by 8. 7 divided by 8. And I get 0.875. So that part was fraction to a decimal. And then I say that's 87.5%. And I will actually write in that we did RipLop going right into percent place. Going from a decimal to a percent is so fast with that scoop to a percent that trying to find some way to directly go from fraction to percent is slower. You can, I could show you some way to do it, but you would always lose the race except for some special ones that just happen to work out fast. So do your division. You have calculators, division is easy, it's the calculator's job. And then scoot twice to the right and ta-da, now you're in percent format. Okay, we could need a repeating decimal, that's okay. So ta-da, now we've done all of percent format. As always, there's lots of videos. There's some best textbook problems. There's a bunch of them this time because a lot of them are really quick. If you're just scooting your decimal point around, then yeah, that's easy. And then we have our 10 problems for the percent format stuff. And if you need even more homework, you have some random problems too. And then we'll get into measurement units, but I'm not going to start a whole new topic with only a few minutes left of class.
Is there someone there?
So
So
are we doing 10 exercises right there, and then the last 3 of the other one for homework tonight?
Yeah, so your homework is to catch up through here. So if you've done the rounding 10 exercises, then you've done that, right? If you haven't submitted a code and gotten 8 out of 10 yet, then do that, either because you haven't tried it yet or because you didn't get 8 the first time. For the fraction 10 exercises, if you haven't done it, then do it the first time. If you tried the first 7 and were happy but didn't do the last ones because we hadn't done ratios and rates, then go ahead and try all 10 and get a code and send it to me. And no one's tried percent format yet. It's a new topic, so try that too. The rounding again has a due date of next class. The others have no due date yet, and I expect they won't for a while. We'll have questions about these at the start of next class.
Okay, thank you.
So just keep going until you're caught up with the percent 10 exercises. Notice you take a break and then come back and it will be
Right.
study session.
You should have left them outside.
So if people are
They're
starving
less noisy.
from work and need to eat something or so on, if you disappear, that's okay. But study sessions are a good time to get a head start on the homework. So maybe I'll see you in 10 minutes. Anyone have other questions before our break?
No.
I said here in the chat, thank you for that, for attendance. And I'm going to stop the recording for now. I can always start a new recording for the study session. But usually if you go to the study session, you get your own Jamboard of what we did then. And if we record it, only you get it, because not everyone wants to hear their questions put on YouTube forever, because some people are embarrassed when they ask questions. So we often don't record the study session.